So here we have number 12, and the instructions are to solve the system by the addition method. The addition method is also called the elimination method. Okay, so in this method, what we're going to do is we're going to manipulate each equation so that we can cancel out one of the variables when we add them both together. Okay, so I'm going to write my equations out here. I'm going to write 3x plus 6y equals 3. And then I'm going to write 2x plus 9y equals negative 8. So I'm going to focus on my x's, and I want my x's to be the exact opposite so that when I add them, they cancel out. So since they're both positive, I'm going to multiply one equation by a negative number. That way one of them is negative. So I'm going to do that to the top. Okay. And now as for which number I'm going to multiply the equations by, it takes a little bit of thought because I can't just manipulate one equation to get opposite variables. But in this problem, I have to manipulate both of them. So what I'm going to do is I'm going to multiply the top equation by negative 2. And I'm going to multiply the bottom equation by 3. Now follow me here. I did that because if I multiply a 3 times a 2, that's the same thing as a 3 times a 2 here. So that's kind of like a little trick you can always use when you're trying to get variables to line up and be opposites. I would multiply this 3 by whatever number's here, and then this 2 by whatever number's here. So we did just that. The only thing added is that I made this 2 a negative. That way, when I distribute the number into the equations, the x variables are exact opposites. So let me go ahead and prove that to you. So when I distribute my negative 2 into each and every term, I get negative 6x minus 12y equals negative 6. And now for my bottom equation, when I distribute this 3 into each and every term, I get positive 6x plus 27y equals negative 24. And so now this system is the same thing as this system, except this is a different size, or they're different numbers because I made them bigger. I multiplied one by negative. But since I did it to the whole equation, that's completely legal. And now we can work with this because when we add it all together, my x's finally cancel out. And when I bring down the rest of my items, I have 27 minus 12, which is 15y, equal to negative 30. And now I can solve for my y. So I'm going to divide everything by 15, giving me y equals negative 30 over 15, which is simplified to just negative 2. Okay, so now I found my y value for my solution, but I still need to find my x. In order to find my x, I'm going to take what my y equals, and I'm going to plug that back into one of these problems, or equations, sorry. And it doesn't matter which one you choose. So I'm going to choose the first one, just because it's the first one. Why not? And I'm going to write it over here. 3x plus 6y equals 3. Now I'm going to write it again, but every time there's a y, I'm going to replace that with negative 2. So I'm going to write 3x plus 6 times negative 2 equals 3. And now I'm going to solve for my x. So I'm going to distribute this 6. So this is going to give me 3x minus 12 equals 3. I'm going to add my 12 to both sides, giving me 3x equals 15. Now I'm going to divide my 3, giving me x equals 15 over 3, which can be simplified to just 5. So now I have my x equals 5 and my y equals negative 2. So my solution for the problem is 5, negative 2.